Hello and welcome. I'm Nick Gibson and I'm joined by John Goodacre, Professor of Computer Architectures at the University of Manchester, to talk about interconnectivity. John, welcome.
Good to be here. Hi, Nick.
Recent reports show that less than 40% of companies currently use interconnected tools to measure, manage and control data and processes that are key to their business. Do you find this, and why do you think this is, and what are they missing out on?
Well, it's an interesting statement. 40% not using the internet, not using databases that connect systems together. It sounds a bit of a low number if I was to not do a survey and suggest. So, is it that the connectivity aspects are not being exposed in a way that the top management of businesses understand, in much the same way that the cyber risks and cyber problems of connectivity aren't always exposed to the management as well. So if finger in the air, I would say that's a very low number when you, depending on what you consider as connectivity. So maybe drill me down a little further what you thought the connectivity bit was, and we'll see.
Well, I was speaking to a number of other people this week, and in fact we put up again another news item up on the website most recently, and it was a survey of CTOs, chief technical officers, who were basically complaining that that management's use of technology and understanding of the benefits of technology was out of alignment with key business objectives. Basically, that top management, for all kinds of different reasons, they've got their processes, and they're not really making the most use of the technology to do that, and leaving the people in charge of technology in their companies rather frustrated. Somebody else also pointed out that in fact it can be very difficult trying to integrate new systems and connectivity systems for improved processes onto what are a lot of existing legacy systems. So it's as much of a practical thing as it is a cultural thing, I think.
Yeah, I would support most of those statements there. I think that there is still what you could class as legacy domains of silos, if you like, of technology. I experienced a modification where they were just trying to integrate holiday booking into their central HR system. And you think, oh, that should be easy, shouldn't it? But actually that took forever, just of the some of the corner cases that had to be involved in that. The other thing that I think I see regularly, and this is more aligned with my role in terms of cybersecurity, is the risks associated with that. Because as soon as you start connecting what historically have been independent systems together, you're having to create a trust model between the two, where you probably, especially if it's outside the company, have no idea how you can trust that as part of your supply chain. And obviously, the recent big leak over in the consumer data over in Australia was basically one of those systems. It was the account system for the thing that had a third-party exposing interface on for allowing partner companies to integrate and interconnect. So I think, while that trust risk is also being elevated as a business concern, as well as the legacy cost issues of integration, I think we are having to look at mechanisms which can sort of help reduce the risk bit, bring a bit more assurance out of those platforms to unblock the CXOs in terms of making what, as you heard, could be a valuable contribution to the efficiency of the business.
I again in talking with people, that in fact data security was one of the questions I was going to ask a bit later on, but certainly if you kind of specialize in architectures, when we get onto things like the metaverse, the Internet of Things, etc., again all this relies upon all kinds of interconnectivity and again connectivity from disparate sources and devices. there's a woeful lack of kind of standards and sort of regulation in this emerging area, and people have been calling for some kind of a standard architecture which will enable all this stuff that everyone will understand, and data security and privacy issues are kind of at the forefront of this stuff because it goes into the metaverse or the Internet of Things, and you don't know where it's going to end up.
Yeah, I think that there's a couple of things going on in this standardization. I think for specific domains of interconnect, like hotels to booking agents, actually it's reasonable. Yes, there is overbooking occasionally, but on the surface, the fact that so many people can have different travel agents booking that one remaining hotel room, and it's, in most cases, I've traveled quite a bit in my career. I've got the room, yeah, you get in. And likewise in stock control for online purchasing, supply chain availability, these are all very much keyhold integrations and interconnects that do exist with fairly well-defined standards on how to do it. But then you can look at other areas and other domains of technology, the digital twinning for industry, for example. How do you digital twin things that potentially have never been interconnected? They clearly need some form of standard way of communication. Now, like I say, there is standard ways of data representation. It's just, how do I get to it in a trustworthy and resilient manner is probably the bigger question that people have on that. So yeah, if you have a specific problem, I think there's solutions to interconnect to solve it. And I gave a few examples there. Is there a generic, I can connect anything to anything? I think there's protocols at the low level thing that define how to transfer data, and there's obviously lots of different ways of doing the security on that. But you're still back to the problem of, even if I've got the security, you may have heard the idea of zero trust between servers in a system. That only works if you trust the other machine doesn't lose its credentials. Okay, so yeah, you have to push it on a little bit further in terms of the vulnerability management and trust that the techniques that other supplier is using will actually bring the level of trust that even zero trust tries to bring. And actually one of my other roles is actually with an institute called UKRI. It's the government's funding agency, and I'm running a program called Digital Security by Design. And that's all about, how do we change these computers so that we can get that trust level of the vulnerabilities up to a level where businesses aren't being, well, unsustainably collapsing by patching, but also they can get the trust level up on such systems to obviously, bring the benefits of the interconnection that you're talking about here.
What it rather suggests from what you said there is we're basically talking about another generation of gatekeepers, which is all very well in theory, but then suddenly you get monopolies, like the internet or Google and their ranking and stuff, and there's a gatekeeper there,
yeah.
which
sorry if I left that. Yeah, sorry if I left that impression from that. No, so the idea of a zero trust system is that you have a network of disparate things where obviously each one has its own assurance and security and resilience principles, and you're able to have a trust relationship that you will allow that other person to talk to you. So there's no gatekeeper involved in that. It's more of a case of, does the technology have the fundamental foundations in which that you can trust them to connect you to approve? A great story. When I was a student back in the 80s, the internet was just starting, if you like. And if I had managed to get myself privilege on one machine on the internet, I had privilege on every machine in the internet. And it was a wonderful lack of trust. Or no, it's the opposite. It was fully trusting. But because I had been a naughty boy and hacked one of the university's computers, I then had basically zero trust. Yeah, everybody had to have a login, but because I have a secure login here, I had it there. And it's really the technology trend, and this is where actually the government side of my responsibility is really starting to get involved. Obviously, they've been working on trying to get product vendors not to ship with default passwords, just to bring up the consumer market to a level of more trust in what you're buying. And the Digital Security by Design program is actually about getting the component vendors up to actually protect the software and the trust environment that they need to create from the vulnerability of attack. And obviously, as those sort of filter down the up and down the supply chain, earlier in the supply chain, it can really impact more and more people to help, you know, the broader community and businesses to connect and have a more trustworthy experience of computers. Okay.
I mean, it does strike me as extraordinary in this day and age. You can understand it, as you say. I mean, I obviously was around at the you know, before the invention of a mouse or indeed Windows, but it still amazes me how many people, organisations, businesses, etc., basically are sailing with their bow doors open. So quite often it is the vulnerabilities and quite often human error which allows data security breaches as much as the sophistication of the hackers, etc. So generally, yes, we need to raise all this. From your point of view, I mean, yeah, everything is data driven. So how do you see the kind of telecommunications aspect of this with 5G and you know, encrypted mobile, and because more and more things now are, especially in terms of remote sensing and tracking and all this sort of thing, the communications, telecommunications aspect of all this is as critical as the data and the hardware side of it, isn't it?
It is, and it's sort of the, you know, there's the three aspects, isn't there? There's the data, the communication, and the compute. And, you know, and that's what the digital world's all around. So you know, it's interesting. Obviously, the compute's been following the Moore's law, just getting smaller and smaller transistors, giving us more and more functionality that runs faster, slowing down. That's obviously hitting points of innovation. Communication, I would say, is still ramping at the speed that's unbelievable, whether that's wired or wireless. You know, what people can, you know, I was reading an article the other day that somebody's got a new laser for an optical cable, which basically says through their cable, they can put the entire world's internet traffic through. So you can imagine what that means to next level of bandwidth. So is bandwidth and connectivity going to be a limiting factor in connectivity in the interconnect? Probably not, in the sense of the physical aspect. Obviously, in the way that it's used and the way that it's delivered, will have impact on interconnection, because clearly if you, again, don't trust who the provider of the pipe is, you've got a problem. And it's all coming back to actually cyber again. You know, one of the ones I've used recently in my research agenda is that end-to-end security is only good at the end of the wire. As soon as you hit the computer, you'll be on the end and it's not secure again. So that's difficult. There was another example that I came into, which is actually a 5G example. Obviously, 5G was promoted as the enabler for IoT, the ability to what they call splice this big bandwidth pipe for different customers. And then I was talking to an early deployer of a data center for IoT services for lots of vendors, and they didn't trust the computers. They wanted a separate computer for every slice of the communication stack. So again, very low productivity due to the security and trust issues. So
I did again put a news story up again this week, and it was about organizations. It's a worldwide study on people's perceptions and experiences of using artificial intelligence. And whilst the use of artificial intelligence in all its kind of different forms, big, small, and indifferent, is obviously rising, again, the majority of the technology officers in charge of all this still didn't trust it enough to basically to use it for full sort of decision making without human input. So they were still using manual and sort of analog back end on these things because they didn't have a full trust in AI's ability, not just its abilities, but again, all the security.
Explainability, yeah. So AI is, having a bit of an academic head on me. What is AI? Well, AI is a new way of programming. Yeah, and in essence, it's probably as big a change as moving from assembler language into high-level languages. It's that kind of transition. So, originally assembler was you knew exactly every instruction the computer was doing. You could fully explain what it was doing. You knew exactly what it was doing because you wrote the instruction that did it. Went into the higher level languages, and you will sort of have this thing called compiler doing some translation of what your intent was. So you look at your code and you hope that what your intent was delivered. That's the world we're living in, and that's the world we're struggling with, because unfortunately computers don't always do as the programmer intended, and even the programmer sometimes makes mistakes in what they intended. And then we're coming to this AI leapfrog, step change, or whatever you want to call it, where they're saying, well, actually, I give in. I stopped trying to make the decisions of what the computer does, let it decide itself, because it can learn a lot more than I can about a problem and make a decision for me. Now, in terms of what your report was saying, yes, big problems in how do I explain how it got the answer, but then you've got two other security problems. Is, do I trust that it actually wasn't biased in some way of actually being hacked in its AI? And then, unfortunately, or fortunately, however you look at it, the AIs of today are implemented in that intent-based high-level language, which can have vulnerabilities and bugs in it. So you've sort of got three failures on it, all to do with secure, or not failures, three challenges, all on the security aspect, the trust of what it does, the way that it does it, and who implements it, all causing the problem that you described in terms of, can I trust this new way of programming, which is proving to be very efficient and can do a lot more than a human can in an imperative language, So yeah, it's on its way, but again, it comes back to security, trust. How do I stop those mistakes of programmers in the implementation causing perturbed operation, data loss, etc.? How do I get the AI itself to both, do what it's supposed, the intent to be, and I can explain what it's doing? So yeah, that's obviously why AI is still a significant opportunity, delivering some significant value already. Yeah.
So it's clear from experience of the transition from analog telecoms to digital telecoms, trying to explain to people 20 years ago, what is voice over IP, and it's all about apps. And we're going through a similar sort of transition now with digital transformation and all these wonderful technologies and applications we've just been talking about. But now, as indeed then, it's something of a conga line, isn't it? Whereby, people rush out to the front and it takes a while for everyone at the back to catch up. So is there an argument to say that because technology increases exponentially greater now than it ever has, because it's being built on much larger foundations and developments, that basically in many areas the technology and the applications around those technologies are racing ahead, and frankly the punters are struggling to keep up?
I think there'll always be early leaders and followers, yeah? That's just the way the business world works. Now, clearly, is somebody that's taking the risk to lead going to get the benefit of the technology? There's a lot of examples in history that says that's not always the case. So the person that leads bleeds, yeah?
If I may interject, there's a well-known expression: is the pioneers are the people who walk around with the arrows sticking out their backs.
That's it. There's lots of examples and metaphors for, there is need to push the envelope, and there will be people, using what I would class as unsuitable technologies as a foundation on that. And, the world of security, just going back to that, is all about the abstractions of something that was sold previously, leaking some information that wasn't considered higher up, whether it's an interface, a database API, or whatever. It's just, how do I make this new app, this new thing, that widget? Well, I pick a bit of that, bit of that, bit of that, and I join them together, and then they look underneath and they go, oh yeah, we'll ignore that. So and the DSDB, the Digital Security by Program, was actually identifying that the world had grown up from the hardware and software in the 40s and 50s, such that software did that, hardware did that, and they've been running in parallel for 40, 50 years. And then somebody says, oh dear, I make a mistake in software, the hardware does nothing to protect it. It's quite happily running hackers code as it is programmers code. What can we do to stop it running hackers code? And we have to get the government, in this case, had to intervene with business to go and say, well, let's fix that foundation. So I think the leaders and bleeders, yes, people are leading the way, but sometimes we have to look back at what we've built. And some of the cloud infrastructure is exactly the same. They started with one big machine with lots of applications. They went into virtual machines. They went into containers. They're now saying, no, serverless and microservices. That it's a big circle. But through none of that progression did they actually say, does the computer help me here to stop bugs? Can the computer actually stop this escalation of vulnerabilities and things like that? And hopefully the answer is yes in the not too distant future. But yeah, leaders and bleeders and arrows in the back, and some of the biggest companies I think have been the followers. But somebody's got to do it. Somebody's got to enjoy the pain.
It is what's very clear in talking to experts like yourself, people at the pit face who've got a handle on the marketplace, is that there's a very big job to be done in terms of driving the future, making the future work, but there's an equally big job in securing legacy issues, legacy hardware and systems. John, I'm afraid we've reached our allotted time, I'm afraid. I know that there's an awful lot more we could talk about this, and I would like to be able to catch up with you again in future and talk about some of the other wonderful things that you're doing in other areas. But for now, John, thank you so much for your time and your insights. I very much appreciate it, and I wish you every success in your future endeavours.
Thank you very much. Good to meet. Thank you. Bye.